Hello, wonderful people. So here we are in Newton's third law, chapter 6. This is a review before we jump into chapter 7, momentum. Newton's third law is that forces come in pairs, and the pair of forces are always equal and opposite in direction. I am the blue, red, green, purple text reader. Have you ever had an interesting interaction with someone? Do you know the phrase, "It takes two to tango"? An interaction is between two people. By definition, it takes two things to have an interaction. So in physics class, interacting things, that means that there are two things that are doing the interacting. One interaction requires two bodies. So in this picture, the male exerts a force on the female, and the female exerts a force on the male. Who is to say which is the action force and which is the reaction force? We generally name the action force the one that acted first. The two forces are called the action force and the reaction force. Action and reaction forces are equal and opposite in direction. If I push on you, then you push on me. The two identical skaters push off each other. The two interacting bodies produce a pair of forces that are equal and opposite in direction. So, do you see at the bottom of the screen? I'm saying that the force applied to the person on the left is equal to the force being applied to the person on the right. Are you with me there? If you have the same mass as me, then you have the same acceleration as me. So if I'm pushing off you and you're pushing off me, and we have the same masses, then the accelerations are the same. And you can see that in the equation, F equals ma. So now I'm saying that the mass and acceleration of the person on the left are equal to the mass and acceleration of the person on the right. Because the forces are equal and the masses are equal, then the accelerations are equal. Now, if I push on you, then you push on me. That's always true. Now, do these two skaters create a pair of forces that are equal and opposite in direction? What do you think? The answer is yes. Forces come in pairs, and forces are always equal and opposite. So the force on the skater on the left is the same as the force on the skater on the right. Now, obviously the skater on the right is bigger, but the forces are still equal. So in the real world, if the big guy on the right and the little girl on the left push off each other, who's going to go faster? She is. Here's why. The forces are equal, but the acceleration of the girl on the left is big because her mass is small. And because the guy on the right has a big mass, he has a small acceleration. So it is true that the forces are equal, but the accelerations are not. Why not? Because the masses are different. Oh, and there, I'm asking the questions. So there's the picture of the previous slide. Are the forces equal? Yes. Are the masses equal? No. Are the accelerations equal? No. Why? Next question. Is the product of little m times big A equal to the product of big M times little a? Yes, they are equal. Why? Because m times a equals force. And I already said that the forces are equal. Why? Because forces come in pairs and they are always equal and opposite. That's a law of nature. So that was the skater situation. Is that any different than the cannon and the cannonball situation? At this point, do you recognize the cannonballer there in the picture? And maybe you remember going over this in class, I forget, sometime late February, middle of March. So let's review the cannon and cannonball situation. There's the cannon on the left and the cannonball on the right. When they get fired, I didn't draw in the explosion, the smoke, smoke and fire and all that. The force on the cannonball is the same as the force on the cannon. Why? Because the force that pushed the cannonball out pushes the cannon backward, and forces always come in pairs that are equal and opposite in direction. Once again, why does the cannon move back just a few inches and the cannonball goes flying out at hundreds of meters per second? Because the cannon has a huge mass. There are a couple tons at least. The mass of the cannonball is small. Even the biggest cannon, the mass of the cannonball is just maybe a dozen pounds, maybe 2 dozen in the biggest ever. So those are the same questions. Are the forces equal? Yes. Are the masses equal? No. Are the accelerations equal? No. Is the mass, is the big M times little a equal to the other part of the equation, little m times big A? Yes, they are equal. Oh, I get it. Because all forces always come in pairs. The end of Newton's laws of motion. And that's the end of kinematics, which is the science of motion. Thank you.